My name's Jeff. I am a product leader within a group called AWS Industry Products, and I run the automotive products. So we build automotive-specific services and solutions for not just automotive customers, but automakers, but also tier ones, et cetera. And we use a model called co-development to do that. So we actually put our engineers right next to our customers' engineers, same with our scientists, our product managers, et cetera, to go and try and solve some really difficult transformative problems. And so today, you're going to learn a little bit about a collaboration we did with Continental. So Brian and Jan will walk you through that. Also, we're going to go over a little bit about the challenges that exist within autonomous mobility, how you can start to think about those problems on AWS. And then Jan will walk you through what Continental does. You probably think of them as a tire company. They do a lot more than that. And then he'll walk you through a little bit about the collaboration and why AWS, why they wanted to work with us to try and build this solution. And then walk all the way through to a demo. So you actually get to see some of the stuff that we've built together. And then we'll wrap up, like I said, do questions at the back. So as I kind of mentioned, these co-development programs that we do with customers are often driven by the need to do some large transformational change. And so when we ended up meeting with Continental months and months and months ago, they kind of challenged us to say, hey, we want to go and figure out how we can get more out of less. They only have so many engineers. They want those engineers to be as efficient and performant as they can be. And they're dealing with a ridiculous amount of data as they're trying to build these ADAS features for their customers. And so the less they have to manage themselves, the better. And so how can we help them build a solution that would cater to all those needs, be as flexible as they want, was kind of what they tasked us to figure out and work with them on. And then how do we start to think about advancing autonomous mobility and ADAS features so that we can deliver them faster, cheaper, better, so that you and your family, when you're in a car and you have lane assist or collision avoidance, you feel a lot more safer because someone like Jan and his team are helping build these capabilities. So with that, I'll hand it over to Brian to kind of walk you through some of the challenges in autonomous mobility today. Thank you.
Thank you, Jeff. Hello, everybody. If you don't mind, I don't know, I can't see all of you, but I'd love it if some of you could just come in so I can see you. If you guys feel comfortable, kind of come in a little closer. Is that okay with everybody? Yep, go ahead, make your way in. It's nice. While you're making your way in, I'll go through a bit of an introduction here. Thank you very much. Also, quick show of hands. Who here has been doing any kind of AV or ADAS development? Okay. All right, I can see some of you. That's why I asked you guys to come up, but thank you very much for accommodating my request. Well, I'm Brian Berezdovan. I get to work with customers just like yourselves all over the world, and for the last 6 years on developing autonomous features. With that, I'm going to walk through some of those challenges and then some of the solutions, and let's get started. First, I'd like to start by setting the tone, right? What am I referring to with autonomous mobility? We're going to use that term a lot. What I'm referring to really is just the combination of ADAS and AV capabilities that exist for vehicles, for automated driving. The Society of Automotive Engineers has classified this automated driving across 6 different levels, as you can see. We see a significant hurdle issue once you go from level 2 to level 3. And the reason, at least our hypothesis and what our customers have told us is that when you go from level 2 to level 3, you're going from a scenario where before level 2, automated driving features, the driver is in control. Once you go to level 3, you're really getting in a situation where the vehicle is more in control. And that has a lot of different challenges associated, but one of them is to ensure that the vehicle is as safe or more safe than a human driver. So naturally, you can imagine that creates significant amount more testing and rigor to ensure that these systems are in fact usable by the public. For those of you who have been working in this space for a long time, and those of you who haven't, hopefully you know the power of ADAS is pretty clear. Even ADAS at the lower levels of autonomy, right? Not fully autonomous, where there's no human needed. Even at the lower levels, it's unprecedented amount of value to society. Specifically, reducing traffic deaths, 20,000 deaths per year. That's roughly 60% across the United States. That could be reduced. Reducing injuries, right? 1.7 million injuries. And then naturally, reducing crashes. So all these together kind of point to the power of even just the lowest level of autonomy features that show up in all of your vehicles. Most of you probably have cars. Those cars, most of them are equipped with features such as automatic emergency braking, automatic cruise control, lane assist, and some of you may be even operating Teslas that support full self-driving, or BMWs and Mercedes that have similar level 3 features. How do you build this capability? Again, some of you raised your hands, you know this, right? But it's important to remember, it's the perception sensors, the perception system is made up of multiple sensors, different types for different purposes, as you can see. For example, camera utilized for medium distance visibility. Radars used for longer distance many times, non-line of sight visibility. And then LiDAR systems that are used for three-dimensional views of the environment. These sensors generate a ton of data. The throughputs are quite high, and they amount to roughly 50 to 80 terabytes per day. So you can imagine for customers developing these systems, they have to have prototype systems, they have to have pre-production systems, they have to have production systems in on the roads, and all this data adds up. Even with a test fleet of roughly, let's just say 10 vehicles, you could be looking upwards of 100 petabytes per year that has to be managed. With all that data, the secret is that not all of it is relevant at the given time for every developer. These teams can scale from roughly 500 developers and engineers to almost 5,000. And at any given time, developers really only need 1% of that data, right? In fact, we've heard from a number of our customers, and I'm sure Jan will speak a little bit about this, that even just finding the right data you want to use at a given time to do your task takes 60 to 70% of the time. So discovery is holding some of our customers back. Similarly, they really need to have, each of the different developers and engineers need a different type of data set. So some of them might be looking for specific data that applies to anomalous road conditions. Some of them might be looking at scenarios where there's potentially a crash, right? And so on and so forth. And getting a wide distribution of scenes is one of the key elements to allowing these developers to actually create the autonomy features that can handle all the variety of scenarios that we run into every day. And so with that, we talk a little bit about how these tasks vary across our customers, and we kind of lay out a couple of the common ones here. The massive amounts of data really are only needed at any given time. Each team kind of has a different job to do, so there's teams that focus on labeling and annotation, right? This is really in order to create like a ground truth data set. There's teams that focus on just the AI/ML training their perception models, training their planning and prediction models, and being able to execute those with their AI and DevOps systems. Similarly, you have to simulate. A lot of times, you can't just rely on real-world driving data. It's not just the data collected from the real world. I've heard roughly 50 to 60% of the data that's used to test the software is simulated data, because frankly, to be able to prove that you're safer than a human requires millions of miles of effectively evaluation. And then naturally, verification and validation to ensure the safety across a number of different scenarios. So to recap, we really have these key challenges in autonomous mobility development, right? We have unprecedented amount of data volume growing into the hundreds of petabytes. We have to support these engineers and developers to be able to mine the data effectively, not be spending 60, 70% of their time to be able to find it. And also for regulatory and compliance reasons, you need to ensure that you have data governance. You need to know what data was used for what. Similarly, as we talked about some of those different data-driven tasks, from annotation, to simulation and verification and validation. Each one of those actually use a different application. Each one of those are a different tool set. They have their own data types, their own formats. In order to really help customers, we need to address these challenges. And then lastly, but not least, the cost of the scale of these systems to be able to run these simulations, to be able to address it as programs change. And what I mean by programs is, you can imagine if you're a supplier and you're working with customer X, right? And they have a vehicle platform that's maybe a robo-taxi vehicle. You have another customer that is an autonomous trucking customer. You have another customer that perhaps is doing just level 3 features in their passenger vehicles that they're selling in a luxury market. As such, you need to be able to scale the capabilities of the development platform for each of these. So now I'm going to talk a little bit about how do we do that. We've seen a couple different variations of this autonomy development life cycle, but I think this does a good job of illustrating, the general pattern that we see. On the left-hand side, you'll see that there's a number of endpoints, whether they be production fleets, whether they be test fleets, potentially human-in-the-loop rigs, and also just the desktops where developers work on and do their own kind of development and simulation. As well as, from there, the data has to be able to be used for all the different tasks. At the heart of the overall cycle, you'll see, is the autonomous driving data. That's the key, right? Each one of these tasks, whether it's the data processing, and analytics to be able to evaluate the real-world data that was collected to determine if you have to go collect more, or whether it's map development, or whether it's the labeling and annotation workloads, or simulation workloads, each one of these really leverage the autonomous driving data at the heart of everything. So that's kind of the high-level view as to some of the solutions we see manifest in a variety of the different customers. So how do customers actually then now deal with that? How does that manifest? And what you'll see here is a somewhat abstracted architecture picture, right, where you have the different functions shown. Just to give you an idea, this can amount to roughly 30 to 50 different AWS services that a customer uses to effectively make this reality available for their developers. So, for instance, on the data ingest and processing, a lot of times you'll see networking using AWS Direct Connect. You'll see data scrubbing, data enrichment, and others using Elastic MapReduce, or perhaps Elastic Container Services, and so forth. On the data lake side, majority of customers use Amazon S3 in terms of for storage, and then use things like OpenSearch or their own Elasticsearch systems on AWS to enable the ability to do scenario search. Some of them also use RDBMSs, such as Amazon Aurora. And the list goes on and on. And so the key here is to really just take in that each one of these functions, is a whole, it's got a whole bunch of services associated with it, and the the complexity that our customers have is significant. So with that, I'd like to hand it off now to Jan to talk a little bit about Continental specific aspects. There you go.
Thank you, Brian. So very well welcome from my side. I hope you are enjoying reInvent as I do, and I hope you will have a lot of fun tonight at the AWS replay. I'm Jan Baudouin, so I'm heading the data-driven development and DevOps organization, so quite a complex name, many D organization. And I'm part of the autonomous mobility at Continental. Let's talk a little bit first about the Continental group. I think most of you are aware of what Continental is, so it's one of the major tier 1 in the world. We are providing immersive curved displays and instrument clusters, amazing multimedia features, but as well safe, intelligent braking systems to all our customers, but as well sensors and all possible electronics that we can get in a car. But I'm sure you didn't know that we are providing tires as well. Let me jump quickly on the autonomous mobility topic. So at Continental, we are developing ADAS systems in more than 20 years. So we were the first tier 1 in the industry bringing an advanced cruise control system in Europe in 2000 already. And today, we have quite various solutions covering up to the level 4 of the ADAS technology. So we are providing safety features like active emergency braking solutions, but automated parking solutions and hands-off cruising functions as well. But we intend as well to bring autonomous tracking technology on the street, on the road in the US by 2027. Of course, we are not only providing solutions, software solutions to our customers, we provide as well components. So this is a bright portfolio that we have, cameras, radar technologies, but as well LiDARs and all the control units that are required to process all this data. I highlighted 2 of them here on the slides. We have technologies in our radar, for example, to detect obstacles around about 500 meters away from the target, from the vehicle. And we are able as well to detect with this kind of radars a child, for example, crossing just behind a car through reflection technologies. In the latest control units generations as well, if we are talking about level 4 tracking, for example, we are talking about 23 sensors generating up to 1 gigabyte of data per second, and we have the processing power in our control units in order to process that. Let's jump a little bit now in our AWS collaboration, and particularly what we are doing together in the field of data-driven development. I know we have a couple of experts in this round, so anybody could draw something similar. At Continental, we have 15 years of experience in data-driven development. It was mainly on-prem in the past, as you can imagine, and we decided to move to the cloud a couple of years back. And today, this is basically the platform that we have designed together with AWS. It's called CAEDGE for Continental Automotive Edge Computers. It's completely hosted on AWS, and it provides all the services which are required to develop our technologies, as I said, from level 0 safety features, but as well to autonomous driving features. We offer in this platform possibilities to ingest up to 1 petabyte of data per day that are getting then processed. We extract all the metadata informations which are relevant for our development, and we bring that to our developers for further usage. The developers are connected to the platform using workbenches, and they are able to cover several use cases of the development cycles with it. For example, they can select datasets for machine learning, for computer vision applications. We are doing, for example, deep fusion algorithm in the latest systems. Or as well, they can use it simply to validate the computer vision that they just developed. So this is called resimulations. We bring basically a lot of data through our latest generation of functions, and we evaluate the KPIs, the performance of the functions accordingly. We offer as well several other possibilities. So we offer as well a possibility to our customers to check the behavior of the function in the field and therefore to have a loop and improve our functions accordingly. We offer as well third-party connections so that our customers are able to interface with us, but as well that our partners, so labeling companies, are able to work together with us. I just wish to mention as well, so if we are talking about machine learning applications and so on, so we are talking for deep fusion about several millions of data. If we are talking as well about resimulation, problem of autonomous driving is a statistical problem. We have to demonstrate that our system is more reliable than a normal driver. And this is something we need to prove with a huge amount of data. So we use as well other technologies like closed-loop simulation. We use as well Gen AI to generate different scenes, but this is a huge effort. We have a couple of challenges with this platform today. So we are driving around about 150 projects in it. And as you can imagine, all the different projects might have a different sensor setups. We have sometimes sensors coming from different suppliers. We have sometimes data coming directly from the customer, so it is a very complex system. The second topic, it's a platform we have built over 15 years. So we are reusing modules that were developed in the past. We are doing refactoring on a regular basis, but we are spending at the present time more than 50% on operation, which is for us not acceptable. Our developers, our people needs to bring value to the product and not basically focus themselves on the tooling. The other thing is scalability. As I said, a truck systems, we need to resimulate around about 5 million kilometers of data. So that represents, with the sensor setup that we have, around about 100 petabytes in a couple of days. We need to ingest a huge amount of data every day to reach this. So we have a scalability problem that we wish to work together with AWS on. And the last thing, autonomous driving is a quite dynamic field. With the arrival of Gen AI technologies and so on, we have a couple of startups coming in with a lot of great ideas. We have our simulation partners with a lot as well. And we were struggling to integrate all these solutions in an already monolithic platform. Therefore, we decided to set a couple of targets to our collaboration. And our collaboration solutions was basically aiming to provide an underlying layer in order all our applications to connect to. Targets are pretty simple. We need to reduce our operational costs. We need basically our developers to focus on bringing value to our customers. And we decided to set us a target of reduction of 60%. The second thing is that our machine learning specialists, they need to spend a lot of time trying to gather all the data sets. We need to share the database. Oh, there is something missing. We need animals in the night by snow or whatever. I mean, this is a problem that most of you are aware of. We need to reduce the time that they need to do that. We need to leverage any possible technologies, particularly Gen AI, in order to succeed in doing that. And last but not least, if our machine learning engineers were able to release time for their operational task, then of course they can improve more the algorithm. They can check, we can have much more loops, we can improve the algorithm and bring value to our customers. And this is exactly what we aim to. Let's have a look now at how we transferred our development. This is the results of the collaboration we did together with AWS. So we built an underlying layer. So we have built on standard managed services from AWS in order to store, first of all, the raw data of our sensors, but as well all the process data from our sensors. And we have built a metadata storage as an underlying layer. But the magic is not happening there. This is pretty standard. The magic is happening in the middle. We have created a set of bases, data services for data-driven development. where we offer all possible services that are applications that we are using on a daily business, that our partners are using through standard APIs. So we have been working with our partners in defining and creating these standard interfaces to facilitate the integration in that. These basis layers is offering services like orchestration and so on. Nobody has to worry about these aspects anymore, and we have a quite flexible architecture. One of the applications as well that was the first consumer for that was an application that we call scene search. This application is targeting exactly to reduce the time a machine learning engineer or validation engineer is using to find the right scenes. And Brian will come back on this in a minute. I was just talking about our technical depth. So we had this cloud platform that was set up with a lot of history, 15 years and so on and so forth. And we were really struggling to integrate latest technologies. We were one of the first, let's say, adopting Gen AI technologies, but it took months to bring that in our monolithic approach. And we wished to change that, and through these standardized APIs, we were able to change this. With our partners, simulation partners, and so on and so forth, we were able to change this integration time from a couple of months to a couple of weeks, generating basically value, but as well giving us the possibility to answer better the needs of our function developers. They come always with nice ideas, great applications coming in, and so on, and this is what we succeeded to do. Now I would like to hand over back to Brian, and he will give us some insight into this scene search feature. Thank you.
Thank you, Jan. All right, folks, so you heard a little bit about Continental's journey into the code development and what we did to collaborate with them to try to solve some of their challenges. One of the outcomes of that was the work we did to develop a Gen AI-based scene search. As we've been talking about, and as Jan mentioned, and I mentioned as well, being able to make sense of this complex driving data across every type of developer, every type of engineer, doing all their different data-driven tasks is very difficult. The main difficulty that we've identified is that they don't always know what they want to look for prior to going to look for it. And so that in itself was a really important aspect that we took into consideration in trying to put this thing together to help their development team, help the engineering teams. With that, we looked at it in a couple different ways. We said, number one, we really need to support state-of-the-art approaches, leveraging generative AI, leveraging ML, leveraging non-ML-based retrieval and extraction capabilities. So multiple models, leverage them effectively. Raise your hand if you've heard of any new foundation models this week, right? Yeah. I mean, I think we just announced Nova, right, with all the multi-modal capabilities. You hear from Anthropic and Mistral and all these great companies just innovating massively. That's going to continue. And so we want to make sure that we built it so that we can solve the data curation, curating those data sets per developer, per engineer, in a simple fashion that takes advantage of state-of-the-art as it evolves. Furthermore, want to make sure that custom annotations that are created by humans in the loop, right, by other ML pipelines and other ML services that, a company the size of Continental, the companies that are working on these problems can take in and can ingest that and be able to gain from those existing investments. Many of them have hundreds, if not thousands, of pipelines that they can reuse. Similarly, we wanted to make sure that customers have the ability, and you'll see this in a moment in the demo, to be able to leverage semantic search in the form of natural language, as well as very structured searches. Combining the idea of semantic, aka flexible. Most of you have probably used ChatGPT or some other ChatGPT-like interface. You're starting to see how these LLMs, these large language models, have capability, and they're manifesting in multimodal models as well. And so we really want to make sure that developers, engineers have an infinite query capability. They can query anything they want, right? They want to look for seagulls in the sky. You can do that. You want to look for pedestrians in the rain with glare. You can do that. And you don't have to rely on anything a priori to be present to actually execute that query and find those very key driving scenes that you need to do your work. And then lastly, we identified that, most of these engineers, most of these developers, one of the main use cases is just, I need to be able to quickly visualize it and be able to, decide whether it's a true positive or perhaps it's a false positive. It's not really relevant. And then I need to create a data set accordingly. So how we did that is we really broke the problem up into kind of three major components. One was really the extraction piece, to be able to leverage multiple different types of models, multimodal models, LLMs, object detection, open source models, anything, and combine them, whether you're doing a global embedding across a whole frame or across a video, a snippet of multiple frames, or whether you're doing local embeddings, and be able to combine these state-of-the-art capabilities. And then going to number two, indexing and querying, right? Being able to support a scalable, we talked, hundreds of petabytes associated with the data. That amounts to a ton of just frames that need to be searched on and tons of annotations and time series data that needs to be made sense of. So scale was really key here. And then supporting a multi-dimensional, multimodal, effectively index was actually a fairly complex, project in its own. And then lastly, supporting that visualization, supporting that activity of curation was key. So having a user interface that could simplify that interaction for our customers and for Continental. So with that, I'll take a moment. I'm going to step off over here, and I'm going to walk through just a brief demo of what we built. I need to control it from over here, so please bear with me. Okay, let me just make sure it's working. All right, so before I start, let me just press it here. The data we use for this demo is from, I am brain freezing with regards to the data set. New Scenes, my apologies, everybody. New Scenes data set, which is an open data set that is collected in Boston and Singapore. And it really consists a lot of like urban scenes, which are, some of the most complex in terms of behaviors and so forth. But just to give you an idea of what the data set is, what you see in front of you is a web-based interface, obviously interfacing with our APIs. And it's pretty simple, right? It's got the query, box. It's got a ability to turn structured search on and off. We're just going to go through and show you some of the semantic and image search functionalities. And it also, has the ability to be able to upload images as needed, and also be able to curate the associated scenes that you consider as true positives. Those would be used for downstream applications such as annotation or simulation, like the ones we've kind of talked about in the past. So what you'll see here is just going through, quick query associated with looking for construction cones. Nothing super complex with the idea of construction cones, but a lot of times you're not necessarily going to build a perception model to specifically identify a construction cone. Some do, some don't. But if you don't, now you have the ability as a developer, an engineer, to be able to search your driving data for these things. And as you can see, some come up, and we preview these, again, just trying to support a fast curation use case, be able to quickly identify whether it's a true positive or perhaps a false positive. It's also important to note that with semantic search in general, it's not intended to be super precise. What's intended to do is catch all the fish in your net. So in this case, we just made a modification to look for those construction cones, but now we realize, hey, we want to be able to search for those, but also search for pedestrians in the rain. And so as you can see, some of these come up. Some are false positives, as you can tell, because the rain may be cloudy, there may be a puddle, but it may not be actively raining. Obviously, we continue to look at different model combinations to improve this, but in the end, this reduces the time for a lot of the developers to not have to create a whole nother ML pipeline just to find these types of scenes, which is commonly what happens. And we have, we return a number of different results, obviously, so that, as a developer, as an engineer, someone interfacing with the system, you could quickly go through, sub-select the ones that are important to you and export those as needed. So this is me fussing around with the associated different scenes to take a look and see which ones are false positive, which ones are true positives. But so you see like a scenario where the interface is, we're doing a search for something that's common, like construction codes or whatever. What I want to illustrate to you now is like the exact opposite, which is you're searching for a complete outlier, something that perhaps your perception system, your autonomous mobility system is having problems with based on, maybe findings you had in testing or maybe just random behaviors. You can do searches for anything, right? In this case, we're doing chicken in the road. Just so happens that, particularly in Singapore, found quite a few of these. And so you'll see that you have the ability to identify those true positives in the scene. So the other, and I'll demonstrate this in a second, is you also have the ability to, if you want to use similarity search, use a similar system. Now you can combine semantic, natural language, similarity, image, and also structured search all in one shot so that you can now look for precise and some of the imprecise stochastic-based searching of the data. Again, this will start showing the outputs of some of the chicken pictures as you see here. So that's it for the demo. I'd like to just quickly recap and provide a call to action. So at the heart of everything you've heard today, that driving data, that multimodal, multidimensional data consists of camera, radar, LiDAR, time series data from the control units, like the ones that Jan had mentioned Continental builds out. That's at the heart of every step of the autonomy development lifecycle. Furthermore, the complex tool chains, the time to integrate these tool chains, each of these tool chains have a different data format, right? They have a different schema. It's a complexity that needs to be dealt with and is key to enabling that data-driven development. Third, Continental, you heard they were able to create some abstractions, effectively middleware-like standardized framework for that autonomy development to reduce the cost and time. And then last but not least, they solved for some of the simplified data abstractions with the scene search functionality that also help their developers move faster on their daily activities. Call to action, please reach out, the AWS representative, if you want to learn more about the collaboration approach. On behalf of myself, Jan, and Jeff, thank you so much for taking the time. Thank you for coming to this session. Please provide feedback when you can. And thank you. Appreciate it.